The chair now recognizes the gentleman from Tennessee, Mr. Fleischmann, for 5 minutes.
Thank you, Mr. Chairman. I want to thank this distinguished panel. It's great to be with you all today. I started many years ago on this committee under Ralph Hall. As most of you know, I'm Chuck Fleischmann. I represent the great DOE reservation at Oak Ridge and all it does. I am also the chairman of the Energy and Water Subcommittee on Appropriations. So as an appropriator, we fund all of your endeavors, and I think this is probably one of the best federal investments I've seen in my congressional tenure. We've got Oak Ridge National Lab, the Y-12 plant, we're building the UPF, uranium processing facility. We have a great legacy cleanup. Science is critical to all of this, and I thank each and every one of you for your advocacy. My first question is going to deal with supercomputing. I was there when we launched Frontier at Oak Ridge National Laboratory. This was the first supercomputer in the world to break the exascale barrier. The machine unlocks new possibilities to benefit our country's economy, competitiveness, and national security through scientific advantage. We'll be able to take more data than ever before, analyze it faster than ever before. For everyone's knowledge, this is the fastest, smartest supercomputer in the world. We have beaten the Chinese and our other competitors. Dr. Kung, can you tell us how the Department of Energy plans to integrate these new capabilities into our existing systems so we can take advantage of big data sets, artificial intelligence technologies, and machine learning, for example, to solve big problems? Thank you.
Thank you for that question. We're indeed so excited and so proud of the accomplishment at Oak Ridge National Laboratory in delivering Frontier, the world's very first exascale computer system. But the job in delivering exascale computer is not done. We have another system that needs to be deployed at Argonne National Laboratory. At the same time, in addition to deploying the hardware, we're also supporting a suite of applications. We want to make sure that these scientific applications can take full advantage of the superpower that these high-performance computers are delivering, and the suite of applications ranging from a new code for predicting cancer, new codes to be used for discovery of new forms of materials, new accelerated technologies, and so forth. So our emphasis has been, how do we really maximize the investment we have made already in exascale computer? And you have also mentioned AI, machine learning, and that's such an absolutely excellent accelerator. We can even derive even more higher performance and efficiency out of systems such as Frontier. So that is our current focus, making sure that we really maximize the precious taxpayer dollars that we have invested in the wonderful machines at Oak Ridge and others.
Thank you very much. This next topic I'm going to open up for the entire panel, but I do want everyone on the dais to understand this. Isotope facilities. We're talking medical isotopes, scientific isotopes, defense isotopes, manufacturing isotopes. The Oak Ridge National Laboratory in Tennessee plays a central role in the Department of Energy's isotope program. In fact, Oak Ridge provides 283 of the 325 isotopes produced by the federal government. Why is this important? Because the only other source of many of these in the world is Russia right now. So Oak Ridge is the source of these key isotopes. It's critically important. Without Oak Ridge's unique facilities, including the high-flux isotope reactor, that's what we call HIFER, nuclear hot cells, and radiological facilities, the United States and many of our allies would have to turn to other sources, particularly Russia, to obtain many of these important isotopes. My question is this. Would you agree that maintaining these facilities used to produce isotopes at Oak Ridge should be a priority to the Department of Energy? Would you also agree that if the United States doesn't maintain our ability to produce isotopes domestically and has to rely on foreign sources, that it could have significant national security implications? Thank you.
Congressman, thank you for that question. We fully agree the extremely important role both stable isotope and radioisotope contribute to the U.S. economic, health, energy, and national security, as you noted. And we take our responsibility and stewardship of the isotope production capability very seriously. including stewarding our facilities at Oak Ridge National Laboratories. As you noted, we are facing a global challenge in producing these isotopes domestically, especially since the Russian invasion of Ukraine. We already dramatically seeing that challenge further cutting into the supply, the dwindling supply of the U.S. Available supply chain of these isotopes. And the DOE isotope program actually has been working on a strategy for 6 years. We didn't wait until the Russian invasion of Ukraine to start worrying about the isotope. In fact, we have 6 years of planning and getting a head start in making sure we have a strategy that really can alleviate the U.S. dependencies on these foreign sources, especially from Russia. So with that, with the funding appropriated to Office of Science, we actually have a number of projects ready to stood up, including the Super C, which is we just had a groundbreaking at Oak Ridge National Laboratory. We're making sure that these stable isotope, which impact science and technology, impact many, many important applications, including oil exploration, that we have a stable and adequate supply of stable isotopes. So this Super C facility will be a flagship facility when it's constructed. We're very proud of the progress it has made. Thank you.
Thank you very much, Mr. Chairman. I yield back.
Gentleman's time is